Still wakes the deep. An amazing game with incredible visuals, especially its monster design. The question is, could I recreate these monster tentacle effects on my own? Let's find out. The first step was gathering references and trying to figure out how this effect was done. What I think is happening is that the line traces are cast in a random directions from creature's body to get the tentacle endpoints. And then meshes, spline meshes or ribbons are used to connect everything together. Once I started working on it, I realized that recreating this effect using blueprints isn't actually that difficult. Yeah, polishing it to the level seen in the game would take time, but since the goal of this video is to challenge myself, I decided to do it the hard way. Instead of relying on blueprints, I wanted to build my own tentacle system entirely inside of Niagara. If you are not familiar with it, Niagara is Unreal Engine's particle system, and it's incredibly powerful. On the surface, it's simple to use, but it can get very technical if you want it to, which is exactly the reason why it is so good. It's basically like having a little Houdini inside of Unreal. This is actually possible to do in Niagara, but not in a very flexible way. I could, for example, create 10 separate emitters, each connecting from a start to a random end position. The problem is that this doesn't scale well. If I wanted more or fewer tentacles, I'd have to manually add or remove emitters, which isn't a good workflow. Ideally, I want to minimize the number of emitters down to maybe 1 or 2 and handle everything procedurally. There is a way to spawn multiple ribbons using a single emitter, and I'll go into more details about that later. But that's not the main problem. The real challenge starts when you need to remove existing tentacles and spawn new ones. In the game, tentacles appear and disappear dynamically, depending on the creature's movement. Despawning them is relatively easy. You can simply kill a ribbon once it gets too long. Spawning new ribbons, however, I'll have to get a little technical here. In Niagara, there are few different ways to spawn particles. You can use spawn rate, which spawns particles at a constant rate. There is also spawn per unit, which spawns particles based on how far the emitter has traveled. And finally, there is a spawn burst, which spawns a specific number of particles at the start of emitter's loop. Since I need to spawn particles during the loop, the most logical options at first seems to be spawn rate or spawn per unit, but that is actually not the case. The reason for that, tentacles, or more specifically ribbons, are made of multiple particles. So if I want to have new ribbon/tentacle, I need to spawn multiple particles at once. I need to spawn group of particles at a constant rate, which sounds more like combination of spawn burst and spawn rate. And there is actually some cheesy way to make that using just spawn burst. First, you need to set loop duration to very low. This will make spawn burst activate every 0.1 second. And then you can use spawn group index to separate particles into groups and for each group to put a different end position. And that works, but that will spawn particles and never stop spawning them. I want a way to limit the number of ribbons that can actually exist at the same time. Let's say I have 10 particles that make one ribbon. That means if I have 50 particles overall, I know I have 5 ribbons. Then I can check if number of particles is equal to 50, and if it is, spawn 0 particles next loop. And there it is, I have a spawner for my tentacles. But wait, what is this other emitter? So, as I told you before, we need some other way to get start and end positions for the tentacle. Because of the way our ribbon emitter works, I decided it's best to make a separate emitter that will calculate end positions and then send that information to other ribbon emitter. So this emitter is kinda a library of possible end positions one ribbon can take. It still needs some polish, but the core logic is working. Next thing I wanted to do is to add a spawn and despawn animations, like this. After that, I added some organic material to the ribbons to make them look more like gooey tentacles. And there it is! The tentacle effect is finished. Even on its own, it looks super cool, almost like Venom's symbiote. You know your VFX is good when you just can't stop playing with it. I can't stop. I might even release this as a VFX pack on Epic Games Store. Who knows? But it's not over yet. I still want to create this. And for that, I need the monster. So I opened up Blender and started sculpting. Now, keep in mind, I have absolutely no idea how to sculpt. Anything I have ever sculpted or will ever sculpt is ugly, gruesome, and awful looking. Oh wait, that actually sounds like a perfect skill set for this job. And here it is. Everyone meet Bob. I rigged Bob, imported him into the engine and added some organic materials and animated him. And also added some jiggle physics. After that, I added some more details like bones and stuff coming out of him. I made another version of tentacle system to create these legs you can see in the original VFX. It's working very similar to the ribbon version, only this is a mesh of a leg I made in Blender. Then I added a couple of tentacles and leg systems to his extremities, animated Bob along the curve, and here it is, the final result. I still think the original is better, but I'm really happy with how everything turned out. It took me about 20 hours of work to recreate it, and I'm very proud of the result. I hope you enjoyed this video, and if you'd like me to release these tentacle effects to Epic Games Store, let me know. I'm curious of what you think. See ya in the next one.